Okay, Musa, how are you?
I'm fine. How about you?
I'm okay. Today is 24, right? Is everything all right, Musa?
Yeah,
How is the celebration of Nowruz? Still celebrating or already finished?
I don't know. No, it was like for 2 or 3 days, but now we had like holidays, and
Hmm,
today was like warm, sunny weather, and it was so good.
I see. Did you go out today?
Now,
No. So you were staying home the whole day?
yeah,
Musa, do you live in a apartment or like detached house?
apartment.
Apartment. I see. Good. Musa, then let's start. Okay. Uh, Now you're only you. Maybe they will join us a bit later. So last time we practiced a few questions, and also we started this 2016 S1, and we have to finish them quickly. And after that, we will move to S2. Okay. And also we need to see some other questions. We have only 4 weeks left, and it was the last question, right? Did we do this question together?
Yeah,
Okay, good. So now we stopped here. Let's continue from here, Musab. Can you read the question?
huh. How will the pattern appear when the transparent sheet is folded along the dotted line?
So it says that how would the pattern appear when the transparent sheet is folded along the dot line, right? It's a little bit tricky question. If you just fold it along the dot line, how does it look?
It is A. I had
A.
yes, I had the mirrors there, and I put the mirror and uh, found it. Find
So how do you put the mirror? You already put the mirror on it?
Yeah,
I see. Good. So the answer is A. It is question 10. How did you do that? Can you show me, Musa? Because here, right, if you just fold this, of course, here it's a bit difficult. Like, for example, here, if I just draw the line again here, this will be here, right? And this will be here. So now if I join this, it will be here, right? And how about this line? It will be also, it moved here, right? And we are just reflecting because we are folding along the dashed line, right? Now, you should just join this one here, right? And after that, if you look at this one, for example, if it just moves up from here, it looks this direction, right? And how about this one? And also it looks this direction. Because if you look at it, for example, this point, right? If reflected, it will come to here. And this point, it will come to here. So if you just join this them, it is just this one. So what is it? It is, let's see.
see? Mm,
Good, this one, Musa, this one is going up, right? Right. And if you look at this one, if you
yeah,
just reflect, it means you are just folding a paper, right? Folding a paper, usually reflection, for example, how do we do that? If I ask you, for example, in the coordinate axis, how do we reflect this above the x-axis? So the same thing, right? Measure the distance, right? Measure the distance here, and this point is not moving, the reflection of this one will be this. If I ask how about this line, for example, right, it will be something here like this. So here, to reflect this one above the dashed line, right, if you just move this point into here, because the distance must be the same. As ruler, you can do this much better. This point, it will be moved here. This point must be the same. And also, well, this actually, I don't have to do one by one. Since it's a straight line, just actually reflect this above the line. Its image will be here. And at this point, it will be here. Now just join them with a straight line. The second one here, for example, right, and it will be this. And after that, if you reflect this, actually it will go to here. And this will go to here. So if you just join it, it will be this. So the idea is, Musa, just you need to reflect to their endpoints. And after that, just join them. It gives us the reflection of the picture. Okay.
Hello, teacher.
Hi, Maka. Hello,
Okay.
Solomaka. We have just started, okay, and as you know, we started this paper S1 from 2016, and we are doing this question 10. And the question is, actually, we just draw something here. The question is, let me erase this. The question is, how would the pattern appear when the transparent sheet is folded along the dot line? So that means that if you just along this line, right? If you just fold this along this line,
Yes, I
how
got
would
it.
it appear then? Huh?
I got it.
What is the answer? Which one?
C.
C,
Yeah.
right? That is C. Okay. It's about reflection, actually. Reflection, just reflect the point and join with the ruler. That's it. Let's move to the next question. Maka, can you read the question?
Yes. There are 11 regions in the diagram on the right. Each region is to be painted with one color. What is the least number of colors needed to paint all the regions so that any two adjacent regions do not share the same color?
Okay. So again, it's a kind of, what is it? Usually this idea is used to make a map, right? If you just look at the world map, for example, and you do not see any two countries, they share a border, but they have the same color. We don't have such countries. Maybe two different countries, so two different continents, they may have the same color, but we don't have any two countries, they have the same color or shaded with the same color and sharing the same border, sharing their borders with each other. We don't have. That's actually this mapping idea, but here it says that there are 11 regions in the diagram on the right. Each region is to be painted with one color. What is the least number of colors needed to paint all the regions so that any two adjacent regions means sharing some border, right? Adjacent means sharing some border. So adjacent regions do not share the same color, right? So how do we do that? You can just start from anywhere. For example, uh, I can just put some colors. Let's say color 1, color 2, color 3, color 4, color 5, color 6. I have a lot of different colors, right? So here our job is to use minimum number of different colors. Okay. Guys, can you think for like 1.5 minutes, and after that, let's see who can say what. At least you'll just tell me the idea. How can we do that? 1.5, 2 minutes, let's say. Let me just bring some water. Just a minute. Sona, any idea?
I guess like my answer is D6.
6?
Oh yeah.
Not less than 6?
I don't think so.
Musa, Makkah, how about you? Is your
My
answer
answer is my answer is A3.
3?
Yeah.
How is that possible?
Like there are like three main colors, red, yellow, and blue, and if we mix them, we gain how to say all of the colors.
Okay, let's say Musa, you are saying that because Sona's answer is too big, your answer is too small. Okay, you're saying red, yellow, and black. Doesn't matter. Let's say one,
Blue.
two, three. So where
No,
should I start? Huh?
blue. Like we can mix them and gain new colors. Like it's a
No, no,
main
just tell
color.
me here. For example, if I start here one, for example, let's say color one. Let's say this red something. So let's say this one is number 2, second color. So this one, it cannot be 1, it cannot be 2, right? The only thing is it should be 3, right? So how about here? It cannot be 1, it cannot be 3, it should be 2. How about here? It cannot be 1, it cannot be 2, so it should be 3. How about here? It cannot be 1, it cannot be 2, it cannot be 3. So I have to use different new
Oh,
color here, right, for this dot.
Yeah, mix them.
So that minus 3 is not possible here. So and actually, let me use 4, for example. Let's say 4. Okay. At the time here we have 2 and 4. I can just write here 1, for example. And 2 and 3, I can write here, for example, what is it? 4. And 3 and 2, I can write here, for example, 1. And 2, 3, I can paint this with color 4. And 4, 3, I can write here 2. So now, Sona, can you see any two different regions sharing the same, I mean, they're sharing the border but the same color? No. If we just pick any two, right? For example, 3, 2, 4. Different. 1, 2, 3. 1, 4, 2. 1, 4, 2, 3. So that means that we have only with 4 different colors. I can color all the regions so that no any two adjacent regions share the same color. Sona, do you agree with me?
Oh yeah.
Maka, what did you get? Did you get anything?
I got a C5.
Hmm. I think 4 is possible, right? Look, only with 4
Yes.
colors we can paint. Okay, good. Let's move to the next question. Maka, can you read the question?
Okay. AB, AC, and BC are the diameters of three circles shown in the diagram. Given that AB divide BC equal to 3 divided to 2, what percentage of the largest circle is unshaded?
Okay. Here in this kind of geometry questions, if you have iPad or Samsung tablet something and draw on it, it will be great. If not, you need to print out, then try this, because just looking at the question doing it's a bit hard, right? If you have the printed paper, that would be great. So guys, give a try, okay? At least, will you have any idea or what method are you going to use? If you can get the solution, it would be great, okay? Then let's do this together after 2 minutes. I think question is clear. Maka, did you understand the question?
Yes.
So actually here, how many circles do we have in the picture? We have 3, right? And 2 of them are drawn inside the big circle. Then they are not, let's say we are just cutting off those pieces from a big circle. So they are the diameters of the 3 circles shown on the diagram. Given that AB to BC is 3 to 2. What percentage of the largest circle is unshaded? What percentage of the big circle is unshaded? What does it mean? It means that what we are going to find here is we have 3 circles, right? Let's say the biggest one is, let's say we have A1, the biggest one, and the second one is A2, and the third one is A3, right? So what percentage of the largest circle is unshaded? That means that 2 small ones, that is A2 plus A3 over, here we have A1, the biggest one, right? And times 100%. It's asking this, right? So we have to find this. Sona, did you get anything?
Oh no, not yet. I'm still calculating.
It's a very easy question, Sona. Musa, how about you?
I'm calculating too.
Okay. Maka, how about you?
Me too. Calculating.
Come on, calculate faster. Sona, why is this taking so long time?
I I got I got 13.
13?
Yeah, but I don't know why.
But it says what percentage, right?
Yeah, 13%. But I
Look
don't know why.
here, AB to BC. That means that if AB, that's the diameter of the second biggest circle, AB is equal to 3x, right? And BC, it should be equal to 2x. And how about AC then? AC should be equal to 5x. So that means that that's the biggest radius. I mean, the biggest one, let's say this R1, the radius equals 5 over 2x. The second biggest one, let's say R2, that is 3 over 2x. And third one, the smallest one, 2x over 2, That's equal to just x. So what is A2 plus A3? We know that the area formula is just pi r squared, right? The area of the circle is pi r squared. So now from here, A1 plus A2 over A3 times 100%, which is equal to what is A1, A2? So A1 is pi, right? Let me just keep this outside. Here we have R1 squared plus R2 squared. What is R2 actually? R2 and R3, right? It's not R1 here. It is R2, R3. R2, R3, and here we have RA1. So R2 squared, that's equal to, what is it? 9 over 4 plus R3 squared, that's just x squared. Take this out. And here we have x squared because it's a common factor. Over, how about A1? A1 is pi times R squared. R1 is 5 over 2. That is 25 over 4 times x squared. So times here we have 100%. That's it. Pi cancel each other. X squared equals each other. And multiply numerator and denominator by 4. So here we have 13 over by 4, 25 times 100%, which is equal to 52%.
But I did the same way, but like, how to say,
But what happened, Musa? Where did you make a mistake?
I don't know, maybe because I made
Musa, could you write this expression?
yeah, sorry, my Wi-Fi is very bad. Yeah, I know, maybe in how to say calculation is my mistake.
Musa, now after this step, you should not make any this kind of mistakes because you're practicing a lot of problems, right, for a long time. So you are getting very close to Sasmo. Now you need to be fast and you should not make any mistake. Okay, let's move to the next question. Sona, can you read this question and do it for us? I think you are good at logic questions, Sona.
Okay. What is the largest number of statements below that can be true at the same time? Antony is a lawyer. Antony is an unlucky man. Antony is a lucky man, but he's not a lawyer. If Antony is a lawyer, then he's not a lucky man. If Antony is a lawyer, then he's a lucky man. Oh, 1 second.
That's a very interesting question. Anton is a lawyer. Anton is an unlucky man.
Oh, two.
What was
3
the
maybe.
question? What is the largest number of statements, right? Largest number of statements below that can be true at the same time. Largest. Maka, what is saying?
3 maybe.
Maybe?
Yes.
Oh, I think not. I mean,
Okay. Here, if you look at the first three statements, right? Actually, so Anthony is a lucky man, but he is not a lawyer. If this one is true, this must be false, right? If Anthony is a lucky man, so Anthony is an unlucky man. So also this must be false now, right? Because here we are saying that Anton is a lucky man, but he is not a lawyer. He is a lawyer. He's a lawyer. Okay, Anton is a lawyer.
I think B2, B3.
can I explain my answer?
Yes.
So let's say Antony is a lawyer, and let's say it's true. And then let's say if Antony is a lawyer, then he is a lucky man. So if we take these two, oh no, wait. Oh, it's three.
3,
You
right?
know why? Because Antony is a lawyer. If Antony is a lawyer, then he's not a lucky man. And then Antony is an unlucky man. It makes three. So like the first statement, second statement, and the fourth statement.
Okay. If Anton is a lawyer, then he's not a lucky man. And because here, if Anton is a lawyer, then he's not a lucky man. If Anton is a lawyer, then he's a lucky man. That means that one of them must be true, right? Because
Yeah.
if number 4 is true, then number 5 is not true. If number four is false, then number 5 should be true. Minimum, at least one of them is true. And how about from here? 2 of them can be true. For example, let's say it says, because here in the question, we are not asking minimum, they're asking the maximum, right? The largest number of statements. For example, out of these 3 statements, can 2 of them be true? Yes, for example, Anton is a lawyer. Let's say it is true. And Anton is an unlucky man. If it is true, then if he's unlucky man, then he cannot be a lucky man. This one is false. Let's see here, these 2 can be true, right? At the same time. And but here from the last 2 sentences, only one of them can be true. So maximum, it can be only 3 statements can be true at the same time. So what are these? For example, Anton is a lawyer. Okay. Anthony is an unlucky man. Okay. And Anthony is a lawyer, but Anthony is a lawyer, then he is not a lucky man, right? Number 1, number 2, and number 4, they can be true at the same time. So it is 3. Okay, Makka, did you understand?
Yes, I said 3.
Good. Let's move to the next question. Makka, read the question.
Okay, 4 circles are drawn on a flat surface. What is the greatest number of regions that can be formed on the surface?
Okay, guys, you have 2 minutes. We did a similar question before, I think, a few times. We draw a circle and a triangle. We draw a circle and a quadrilateral. And we draw a circle and a rhombus, right? But this time they are asking that on a surface, okay? Not on a rectangular piece of paper, on a surface. So it doesn't have any boundary. So on a surface, if you draw 3 circles, what is the greatest number of regions we can form? How many circles? 4 circles, I see.
$12?
Really?
Yeah.
Let's see for others. Makka, Sona.
Yeah, I found 13.
13. One more than Musa. How about Sona? Sona, we are waiting for you. Why? It's taking so long again. How many did you find?
Wait, are you calling me?
Yes. We are waiting for you.
What?
Did you draw 4 circles?
Yeah.
How many regions could you find?
14.
14. Musa,
Yes.
12. Makkah, 13. Sona, 14. And also, actually, I found 14. I think then the answer is 14, because if you can prove that it's 14 is true, then automatically Musa, Makkah, your answer is correct, incorrect, because your number is less than our answer, right? If it is more than that, at the time I would listen to you. Anyway, Musa, here again, you should not forget that outside these all circles, and actually to create maximum regions, right, the circles should intersect each other at 2 different points. So that means that here they should not touch. If they touch, there will be only 2. Now here 1, right? And I can draw another one like this. Suppose it's a circle. And I can draw another one like this. Okay. So now if you count the regions, here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What did I miss here, Sona?
Oh,
There is a little one. Belong to 8 and 9. Between.
Oh, here, right? I should draw like this, actually.
Yes.
Here, 11, 13. And here outside we have
and
14.
yeah.
So we have 14.
You
Um,
have something like this, but not like 3 in row and 1 in the bottom.
teacher, I did not count the outside.
So we should count also outside, because it says the greatest number of regions, right? That can be formed on the surface. Also, actually, outside the region is also another region, right? So suppose Makkah, you are playing a kind of game, right? Everybody actually will just going to draw a line so that you cannot cross the border. So how many people can play this game? Then it's 14 people. As see here, one person standing outside. Maybe he's a guard actually, and other people they are just standing in their own region. That's the tricky part, guys. Don't forget also outside you should count this as one region. Okay, let's move to the next question. How many triangles are there in the diagram? And first, before we start this, just tell me the idea. Like Maka, for example, how would you count the triangles here?
Mm, I don't know.
Sona, do you have any idea?
What?
The question here is, how many triangles are there in the diagram below? How would you
One
count it?
second, I
What
will
method?
count them. I'm still in the middle of counting them.
Huh?
Can I count them and then say?
Yeah, I mean, how are you going to count? How?
Just like normally, just like 1, 2, 3, 4. I don't know. Just like
I think in this kind of questions, you need to count the triangles that has only one part. And after that, that has 2 parts. And after the 3 parts, at that
26,
time, you don't get confused.
26.
Like, for example, one part, right? What question is it? It's 15. It is, for example, how many triangles we have here that has only one part? Let me change the color here. How many? 1, 2, 3, 4, 5, 6, 7, 8.
26.
Also down 8. So here we
oh,
have
I got 26.
26. You got 26. Maka, how
Yes.
many did you get?
I'm
26.
26. Musa?
I'm to 26.
26. Let's see. How about 2 parts? And as you see here, this one, 1 and 2, right? 3 and 4. And after that, 5 and 6 and 7 and 8 and 9 and 10. So here we have 10, right? And sorry. And how about 3 parts? I think 3 parts, they don't form a triangle, right? 1, 2, 3, the 1, 2, 3, they don't form. How about 4 parts? We don't have. How about 4 parts? Sona, can you see any triangle that contains 4 parts?
No, I don't think so.
How about this one? Look, let me use red so you can see much better. How about this one?
Oh, I didn't even pay attention to that.
It's also a triangle, right?
Yeah.
It has four parts.
Yeah.
And how about down parts? Also, it's a triangle. Another one, and that's two. And how about? Do we have any other
Yeah,
one?
I think it's B.
Like, can't we just convert it and just count it as like 4? Like if it's 2 and then if we put it in the other side, it's gonna be like
Yes. So it will be
2.
four, right?
Yeah, so it's gonna be 30.
So it's 30 triangles. The answer is 30. Good. So you should be a bit careful in counting. Always check your time one more time. And because always in Sasmo, they ask this kind of tricky question. If you just miss one part, you get wrong answer because your answer must be 100% correct. Otherwise, you will not get any points. Okay. What? Two 2016 S1. Guys, give me 1 minute, okay? I think I forgot to put the questions here. 2016 S1, 16. 2016 S1. 16. Okay, let's continue. As we have 15 minutes left, let's try to solve. As you know, question from 16 to 25, they are a little bit harder questions. That's why for each correct answer, 4 points are given. If your answer is wrong, you don't actually lose any point, but you don't also get any point. But this multiple choice questions, if it is correct, you get 2 points. If it is wrong, you get -1 point. If you don't answer anything, it is just 0. So that is a big question. Maka, can you read the question?
Okay. The bar chart below shows the number of cars sold in Zone A in the first half of year. For example, 4,700 cars were sold in January, while X,000 cars were sold in February. The number of cars sold in June is double the number of cars sold in February. The average number of cars sold in each month is 5,400. What is the percentage increase in the number of cars from May to June? Round off your answer to the nearest whole number. For example, if your answer is 9.56 percentage, then you write your answer as 10%.
Okay. So now we are talking about, usually they never put this kind of question. I think after 2016, they also actually started asking questions related to statistics, because nowadays you know that statistics is very, very, how to say, important field of math or science, and especially in the USA, if you are going to study, for example, data science, right? That's a new field, and a lot of people are interested, and also there are a lot of jobs for data scientists. Because now, as you see, after COVID, a lot of people they are using technologies and the computers and blah blah. So data scientists actually they have very important job to do this kind of stuff. Anyway, data scientist means you're just combining statistics with computer, okay? And that's called, and you're just analyzing data using some software programs. So that is because the bar chart and blah, 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 this is taught in statistics. Once again, everybody, let's read this one more time. After that, we will look at the bar chart and try to answer the question. The bar chart below shows the number of cars sold in town A. So we are talking about this bar chart. as you see here, in thousands, right? In January, 4,007 cars were sold. In February, X cars. In March, 3.35. In April, 5.6 thousand. May, 6.9 thousand. And June, Y cars were sold. Okay. And it says in the for example, 4,007 cars, all right. The number of cars sold in June, the number of cars in June is double the number of cars sold in February, right? If you look at this in February and June, it says that twice means that Y is equal to 2 times X, because here it says that the number of cars sold in June is double the number of cars sold in February. The average number of cars sold in each month is 5,400. How do you call this in math? Actually, we call this mean, right? That mean is we usually X bar. So that's equal to 5,400, but everything is in thousands. So that's just equal to, instead of 5,400, we need to just use 5.4, right? Anyway, so what is the percentage increase in the number of cars from May to June? What is the percentage increase from May to June? That is a very easy question, right? I think it's not so hard. First, we need to write the average formula. What is the average formula? It is 4.7 plus X plus 3.35 plus 5.6 plus 6.9 plus Y over how many months? 1, 2, 3, 4, 5, 6, and divided by 6, that's equal to 5.6. Now from here, we can get the value of X, and after that, we can get the value of Y. And to find the percentage increase, right, how do you calculate this? The difference is Y minus 6.9 over based on 6.9 and multiply this by 100%. That gives us the percentage increase from May to June. Okay, let's do this. Okay, you have 2 minutes, and
It's
after that,
70%, maybe. No, wait a minute.
what is it?
10%. I found.
10%. Are you sure?
I found it. Yes, maybe. It's
Musa,
10%.
Donna?
One second.
Yes, Sona, Musa, did you get anything? Sona, still 1 second.
What?
And you said you needed one more second. What happened? You didn't tell me any answer yet. What did you get?
I don't know. I got a decimal. I don't know. I think it's wrong.
Okay. All right. Sona Maka Musa. Here the average value is, we should just add these values and divide by the number of data here. We are talking about six different data. One, two, three, four, five, six. We should add them together. And y is equal to 2x. That's why I wrote 2x. And what we have here, just simple linear equation. X plus 3x, 2x, that's equal to 3x. 4.7 plus 3.35 plus 5.6 plus 6.9, that's equal to 20.55. First, multiply both sides by 6 and take 20.55 to the right hand side and divide by 3, so we get 3.95. So that means that the value of x is 3.95. Now from here, then what is y? Y is equal to 2 times x. So what is x? That is 3.95. So that's equal to 6. That is 7.90, right? Is it? 687.90. So now it says that, what is it? Round of your answer. What is the percentage increase in the number of cars from May to June? So May to June, so that is 7.90 minus 6.90 over 100, I'm sorry, over 6.90 times 100%. And 7.90 minus 6.90, that's equal to 1, right? And here we have 100, so that's equal to 100 over 6.9%. So if you divide 100 by 6.9, that's equal to 14.49. So that is 14.49. So that's equal to, what is it? 14%, correct to the nearest whole number. So the answer is 14%. Maka, how did you get 10%? Maka.
I get the same answer.
Musa, you get the same answer? Very good. If you got the same answer, that's cool. Yeah, let's have one more question, and after that, we'll finish the class then. Let's see. Musa, again, you disappear. Musa, are you there?
Yeah,
Oh, what's wrong with your internet connection problem?
yeah, my Wi-Fi is awful.
Hmm. Okay. So question 17, it says a prime number P is a Sophie Germain prime if both P and 2P plus 1 are prime numbers. Number 5 is a Sophie Germain prime such since both 5 and 11 they are prime numbers. How many Sophie Germain primes less than 60 are there? Okay, it says that both are prime. What are those less than, for example, 60? First, we need to write all of these prime numbers. After that, we will choose, right, which one satisfies. So it says that, what is it? How many Sophie Germain primes less than 60 are there? What prime numbers do we have less than 60? They are 2 and 3 and 5, 7, 11, 13, 17, 19, 23. And here we have 29, 31, 37, 41, 43, 47, 53. What is it? 53 and the 59. So actually to be Sophie, what is it? Prime numbers, right? What is it? 2 times, if both P and 2 times P plus 1 are prime numbers, at the time that P is called a Sophie German prime. So here, 2 times 2 plus 1, it is 5, yes. And 2 times 3 plus 1, it is 7, yes. 2 times 5 plus 1, it is 11, yes. 2 times 5, it is 15, and 14 plus 5, 15, No. And 2 times 11, 22 plus 1, 23. Yes. 2 times 13, it is 26 plus 1, 27. No. 2 times 17, 34, that's 35. It is not a prime number. 38, 39. No. 46, 47. Yes. And 58, 59. Yes. 62, 63. No. And 74, 75. No. 82, 83. Yes, it is 86, 87. 87, it is 15. No. 94, 95. No. 106, 107. Yes. And 118, 119. It is 119 is a prime number. No, right? Because 7 times 17, I think 7 times 17, it's divisible by 7. No. Anyway, so what is it? The question is how many? It is 1, 2, 3, 4, 5, 6, 7, 8. So actually the answer is only we have 8 Sophie German prime. Because that's the only way to calculate this. Otherwise, we cannot calculate this. We don't have any general rule. So you have to write them quickly and just count them. Okay. All right, guys, thank you very much. We will continue. Today is Wednesday. Oh, we have class on next Monday, right? So keep practicing.
Yes.
Musa, if you finish questions, Maka, Sophie, Sona, if you need more questions, just let me know, okay? Mr. Kasim, I finished the papers. I need new paper, then I will give you, okay? So because we have only 4 months, I suggest you to practice a bit more, and hopefully you will get good result and make your parents and everybody happy, and also you will enjoy it. Thank you very much, guys. Have a nice weekend. See you next Monday. Okay, bye
Okay.
bye.
Bye bye.
Bye.
Thank you, Sophie. Bye bye.
Thank you. Bye bye, Musa.